Hello, this is the luckiest maths teacher in the world. Thank you for tuning in as we review everything you need to know for the upcoming test on transformations. So firstly, before we understand transformations, we have to understand this thing here. This is called the Cartesian plane. It is two number lines perpendicular at 90 degrees with each other. So these two number lines are called axes. The axis that is going horizontally is called the x-axis, and the one going vertically up and down is called the y-axis. So in the Cartesian plane, we plot points. So for example, you see point A plotted here. So the way we write a point, we always use these two round brackets for a point to indicate an ordered pair. So A has coordinates -2 and 0. We always write the x coordinate first. So starting here, 0, 0, which is the origin, we've gone across to -2 on the x-axis, but we didn't go up on the y-axis. So that's why it's 0. On the other hand, for point B, if we start at the origin where the two axes meet here, we didn't go across at all on the x-axis. We went 0 along the x-axis, and then we went up 1. So the coordinates of B are 0, 1. You must have these brackets. Now we're going to plot a point, C -2, 3. So starting at the origin, we go across 2 along the x-axis. Here we are at -2 because we went to the left, and we go up 1, 2, 3. This is where point C will be. So to indicate it, we just put a dot there, and I'm just going to call that C. So it turns out A, B, and C form a nice little triangle there. So what I'm going to do with this triangle, I'm going to translate, rotate, and reflect it. So first we better understand what those words mean. So the three transformations you need to know are translations, rotations, and reflection. A translation is just a slide. If you take a shape and translate it, you just move it. You don't change its orientation at all. You move it left or right and or up or down. A rotation, on the other hand, is a turn. So if you start with a shape like this, you might turn it so it looks like that. That is a rotation. A reflection is the one that people are always talking about, mirrors. So you might start with a shape like this and you flip the shape. So slide for translation, turn for rotation, and flip for reflection. Now note, you can perform more than one of these on a shape. You could translate then rotate a shape, for example. So we're going to perform each of these transformations on this. So how do we do that? Well, first let's do the translation. We're using this is called a vector. Note it has square brackets, unlike the points that have round brackets. The first number tells you how far you go left or right, the second up or down. +4 first means I'm going to go 4 to the right, and -3 second means I'm going to go 3 down. So how do I actually transform this shape? What do I do to it? Well, I don't want to take every single point along these lines. I'm just going to translate each of the corner points. So A is here at point -2, 0. I'm going to move it 1, 2, 3, 4 to the right and 1, 2, 3 down. A will end up here. This is the point 2, -3. So when writing this new point, we call it A dash. That means the image of A. It tells us this is the point where we ended up if we start at A. So we're going to do the same to B. So B was here at 0, 1. We're going to move it 4 to the right and 3 down. 1, 2, 3. It will end up here at the point 4, -2. So once again, I write it with a dash. This tells me that this is where B ended up. Now we're going to do the same for C. So C is over here. We're going to move it 1, 2, 3, 4 to the right and down 3. C is going to end up there. So once we've moved the three corner points, all we need to do now is join them up. We have translated this shape to this. These two shapes are the same size and shape, and when you translate it, they have the same orientation. They're just in a different location in space. All right, we've done the translation. Now we're going to rotate the shape 90 degrees. Now, if you're not given a direction, it always means anti-clockwise. You can either rotate a shape clockwise or anti-clockwise. So we're going to rotate the original shape 90 degrees anti-clockwise. So in the Cartesian plane, the quadrants are labeled in an anti-clockwise direction. You start top right is quadrant 1, then quadrant 2, quadrant 3, quadrant 4. So for us, if we start in quadrant 2 and we go anti-clockwise, rather than going this way, which is the way our clock goes, we're going to go the opposite way. We're going to go back this way. We're going to end up with a shape in quadrant 3. So how do you rotate a shape? Well, you rotate each of its vertices. So let's start here at A. So if you want to rotate a vertex or rotate just a point, what you do is you draw a line from the shape to the origin. The origin here is our center of rotation. We're basically moving everything except the origin. It stays where it is. So we draw a line from A to the origin. That's 2 units. Now we're here. We need to draw a line that's 90 degrees. That way would be clockwise. This way is anti-clockwise. So we need to draw a line in this direction, but it has to be the same length. So this line was length 2, we went across 2, so now we're going to go down 2 so that they are the same length. So A is actually going to be moved there, and once again we call it A dash. Similarly for B, we would draw a line from this point to the center of rotation to the origin. Now we can either go 90 degrees this way, which would be clockwise, or 90 degrees this way, which would be anti-clockwise. Turns out B is going to end up here, and so I'm going to write B dash. So this is not an easy thing to do and usually requires a protractor, but you might think of a different way that we could do this. You see, when we rotate a point 90 degrees anti-clockwise, we just do a little trickery with its coordinates. You'll see the point A started as -2, 0. It ended up as the point 0, -2. The point B started at 0, 1, and it ended up as -1, 0. What's a quick way that we could rotate a point 90 degrees anti-clockwise? Well, what's actually happening both of these is we are switching the x and y coordinates and then changing the sign of the x coordinate. So we can write that algebraically. If you start with point AB, what you do is you switch the coordinates around, the x and the y, and you change the sign of the x coordinate. So what that means is C is point -2, 3. If I want to rotate it 90 degrees anti-clockwise, all I do is switch around the x and y value and change the sign of the x coordinate. So C is actually going to go over here to -3 down to -2. C is actually going to be there. So that's a quick way that you can do it, and then we just draw up the shape. Okay, so these two shapes are supposed to be the same size and same shape. Obviously, I'm just a little inaccurate on my iPad here. All right, let's now look at reflecting the shape about the y-axis. So the y-axis is this line here. We're reflecting the red shape about this y-axis. This is our mirror line. So anything that's already on the mirror line like B, it stays exactly where it is. So I'm going to write my B dash there. B doesn't move. It's a fixed point. Anything on the mirror line stays. Now, how do we reflect a point like A? Well, what we do is we draw a line to the mirror line. We've already got one here. And then you simply extend the line so it's the same length. So I went 2 units here. So I'm going to go 2 units here. Turns out A is going to end up over here. And I write A dash to indicate that's where A ended up. So for point C, it started here. We draw a line to the mirror line and we keep it going, so same length. So C will end up there. Once you've plotted all the new points, you simply join it up. So the blue is a translation of the red. The yellow is a reflection of the red shape. and the green is a rotation of the original shape. Let's now look at rotational and reflectional symmetry. So two types of symmetry, rotational and reflectional. So when you're asked if a shape has rotational symmetry, you're asking if you rotate a shape a full 360 degrees about its center, how many times we have the same shape in the same orientation. Remember, orientation is the way it faces. We want not only the same shape, but we want it to be facing and located in the same place. Reflectional symmetry, you're asking how many lines can be drawn so the shape can be folded exactly in half. So let's look at this shape here, which is a rectangle. Firstly, we're going to look at rotational symmetry. So this is its center. Can you rotate this shape about its center and get the same shape? Well, it turns out for any shape, if you rotate it 360 degrees about its center, you get the exact same shape. So every single shape has order of rotational symmetry at least one. The order of rotational symmetry is how many times we will have the shape in the same orientation. So every shape has rotational symmetry at least one, but some shapes have more than one. For a rectangle, you don't need to rotate it a full 360 degrees about its center. You only need to rotate it 180 degrees. If you rotate this shape here 180 degrees about its center, this line will end up over here. This line will end up over there, and these two will switch places as well. You will have the exact same shape in the same orientation. So the order of rotational symmetry of this shape is 2. If you rotate this a full 360 degrees, if you watch it go a full way around, what will end up happening is there will be 2 times when it is the exact same as you see it now. Once when you've rotated it 180 degrees, once when you've rotated it a full 360 degrees. So there is a link between the angle you need to rotate it and the order of rotational symmetry. If you divide 360 by the order of rotational symmetry, you will get the number of degrees you need to move it. So 360 divided by 2 is 180. So this has order of rotational symmetry too. What about its order of reflectional symmetry? We're asking how many lines can be drawn so the shape can be folded exactly in half. So you probably know for a rectangle, this is a line of symmetry. If you were to fold this shape in half along this line, this side would fit perfectly on top of this side. And similarly, if you were to fold it along this line here, you would fold it in half perfectly. This half would fold perfectly on top of this half. Now, that's all there is for a rectangle. Its order of reflectional symmetry is 2. Some people think that this line is a line of symmetry. It's actually not. Take a rectangular piece of paper, try and fold it in half along its diagonal. You will see that this here, this half, doesn't fit perfectly on top of this half. So this has order of reflectional symmetry too, because there are 2 lines we can draw so that the rectangle folds in half perfectly on top of itself. What about this shape here? So its center is marked here. What would happen if we rotate it about its center? Well, if you rotate it 90 degrees, you'll end up with something that looks like this. That's 90 degrees clockwise. If you rotate it 180 degrees, the shape will end up being down here. And 270 degrees clockwise, which is the same as 90 degrees anti-clockwise, it'll kind of look like this. See, in order to get the exact same shape that you see there, you would need to rotate it a full 360 degrees. So if you rotate this continuously 360 degrees, there will only be one time that the shape is as you see it now, and that will be after a full 360 degrees. So its order of rotational symmetry is 1. That really means it doesn't have rotational symmetry. So what about its order of reflectional symmetry? Well, how many lines can I draw to cut this in half? Well, I can draw a line here, and if you fold along that line, this side and this side will fit perfectly on top of each other. Now there's no other lines I can draw, so it turns out its order of reflectional symmetry is 1 as well. Now it was just a coincidence for these two shapes. You don't always get the same order of rotational symmetry that you do reflectional symmetry. It's really easy to draw such a shape. So a shape like this has no reflectional symmetry and no rotational symmetry. So its order of rotational symmetry is 1. You need to rotate it a full 360 degrees. But its order of reflectional symmetry is 0 because there are no lines of symmetry. So just note, rotational symmetry and order of reflectional symmetry are not always equal. Alright, thank you so much for tuning into this video. Best of luck studying, but you will ace the test. I know it. This has been the luckiest maths teacher in the world. Have a great day.